All right, so chapter 0 and chapter 1. Let's start with chapter 0. Any questions there? Like I said, I did not plan on having to make a video because I thought this was review for you guys, but I am willing to start from the most basic. And please don't feel bad asking any basic questions because we need to.
I'm definitely gonna have a few questions. I took the Math 110X class, and that, I don't know if you know, that class is pretty garbage.
Oh, okay.
there's really like no material at all or anything.
Oh.
And so like calculus stuff I can do quite a bit, but it's some of more of like the logarithms or like the I don't know, I guess just some review for some of the things. Like I can do most everything in economics just fine, but there are some like subjects like unions and intersections. Is like, oh man, I'm trying to remember like the brackets, like this one's like continuous or not, just stuff like that.
Okay, yeah, definitely. Let's do that really quick. Let me share my screen on my.
And I think another thing is sometimes you were trying to enter an answer, and maybe you know how to solve it, but the way the system was expecting you to type it was not the right way to do it, and that's another issue with this.
Yeah. So well, I mean, if you are okay, sorry, hold on. I'm trying to start a new page. There we go. That's not what I meant. Okay. All right. If you are trying to put the answer in, math, fortunately, is very rule-based. And I think if you think you did the right answer, but somehow it was marked wrong, it's very likely that you just didn't do it completely correctly. Okay. So that's why actually I think, it is important to review the most basic stuff like Shay was asking. So Shay, I don't know what other questions you might have, but let's just start with the unions and the sets and the symbols really quick. Okay, so when you have a set that is listing everything, you use the brackets. So you can say, for example, maybe, see, is it integers or integers? I can't remember. And like I said, I never learned this in English. So
integer.
Integers, thank you. So integers is a set of all the whole numbers, negative and positive, including 0, right? So you just write this as a bracket, and then dot, 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 because it starts at negative infinity, then, -5, -4, -3, right? And then dot, 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 all the way to like positive, 3, +4, dot, 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 and then bracket. So that's how you express a set when you want to list every single thing in that set. Does that make sense? Okay. Now, when you have a union of two sets, so let's say you can have all the odd numbers, okay? And that is dot, 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 and then, -5, -3, -1, then 1, 3, 5, dot, dot, dot. Whoops. Yeah. Okay. And then all the even numbers. Okay. That is dot, 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 then -4, -2, 0, 2, 4, dot, dot, dot. Okay. And the union of the two, so if you do odd, okay, with the union of even, then that is when you put the two together, add the two together, and include everything in both sets. Okay, so that would be, in this case, dot, 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 then, -5, -4, oops, -3, -2, -1, 0, 1, 2, dot, 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 dot. Okay, so that is even and odd altogether. Anything that's in either one of these sets is included in the union of the two sets. Okay, now if you're trying to do an odd, okay, intersect the even, okay, then that is only finding the common parts that exists in both. In
Okay,
this,
so it'd just be 0 then.
yeah, and this, well, not 0. It's a 0 with a line in it. That means it's a null set. So that means this set doesn't contain anything. Okay, so this set doesn't exist. Okay, it's not a 0 because here we're talking about sets. It's not a number, right? So this is called this little symbol right here is called a null set. Okay, and then other things when you are writing, you know, if let's say you're talking about inequalities, okay, let's say anything that's smaller, so you can say x less than or equal to -2, that's expressed as, you know, negative infinity, comma, -2, and since there's a little equal sign, it's this, what do you call this one? Can't remember.
Just like a bracket, I don't know.
Okay, that's a bracket. Okay, so parentheses in inequality says, parentheses means not including that end, and brackets means you do include it. So if you have, you know, -4 to 8, that means -4 and 8 are both in this set. But if you do -4 and 8 like this, -4 is in this set and 8 is not. It's anything less than 8 because the parentheses here means that end is not included. Okay, and this little square bracket means it is included. Okay, all right.
And this is going to come into play with like limits, right?
Right. Yep.
Okay.
So later on, we'll use this in limits. And also, as we talk about inequalities in chapter 1 and 2, this will come into play as well. Okay. All right. I don't know if that helps answer your questions, but any other questions? Yeah.
I guess the only other question too I had would be something like the radicals. It just, like I said, it's just been a while since I've done any of those more radicals where you have like a huge square root with a bunch of different things inside of it, or like, yeah.
The rules of how to, yeah, let me think. I think what you, I think I know what you mean. So let me see if I can find.
It would be on 0.4, lesson
Okay.
0.4.
Oh, good. If you know the, yeah, okay. If you know the section, that's even better. You can tell me the section. Okay. So, are you saying rules such as, you know, the properties such as, you know, the nth square root, I mean, not square root, the nth root of a times b equals the nth root of a times the nth root of b, this kind of stuff?
Yeah. Mm-hmm.
Okay. All right. Yeah, so these ones, I think you just need to look at these rules. So this is one property, right? Another one is that, you know, if you have the nth root of a divided by b, that equals the nth root of a divided by nth root of b. Okay, right there. And then the next one is when you have the, you know, mth root of the nth root of a, something like that. Then these two you just multiply together. That equals m times nth root of a. Okay, so the way to do this is really just through some practices. Okay. So for example, let's see if I can find something for you to, well, I guess, yeah, for you to practice. But remember one thing though, you know, that the square root of a plus b never equals the square root of a plus the square root of b, okay? That is a common mistake people make. And just because the square root of a times b equals, you know, so just because this is true, okay, it does not mean the top one is true. This one is a wrong one that people often make mistakes on, okay? So let's do some practices together, and then maybe that will help you figure things out, right? So let's see if you can simplify. Okay, let's say you have the fourth root of x times, and you know, raised to the 28th power times z to the 24th power divided by 81. And can you simplify this? I'll give you guys some time and then see if you can figure it out. I guess if you want, I'll show the, see if I can fit all the rules, I mean, all the properties in the same. I can't quite, well, this one, I can't quite fit them all in one screen, so you'll have to look it up yourself, I guess.
So I just sent you an example too of like a question that was on it that we did, if that helps.
Okay. I need to download it first. Okay. Where do I want it? See, where should I do it? Okay, I can't save it there, apparently.
Brother Mark, can you scroll up a little bit?
Yeah.
Thank you.
Yep. Okay, let me know if you need more time. Okay.
Now, Brother Mark,
Yeah.
so with the exponents above x and z right there, is there a way to simplify those with the fourth root?
Yeah, there is actually. So let's just figure this out. Okay, so this, according to this rule right here, this property right here, right, you can divide the fourth root into the fourth root of the numerator and the fourth root of denominator, right? So let's take this slow. So this equals the fourth root of x to the 28th power times z to the 24th power and the fourth root of 81, right? Everybody with me so far? And then in the numerator, we can then apply this rule right here, okay? And so this equals then the fourth root of x raised to the 28th power times the fourth root of z raised to the 24th power. And then the fourth root of 81 is what? So that means, yeah, three times, you know, by itself 4 times equals 81, right? So the fourth root of 81, you just have to figure it out. It is 3 because it's, you know, 3 times 3 times 3 times 3, 4 times. That's what the power means, right? So 3 raised to the fourth power means 3 times itself by 4 times, right? Whoops, not 4. No, sorry, 3. Okay, that's what that means. And that equals 81. So when you do the fourth root of 81, it gives you 3. Okay, so then, okay, the fourth root of x 28th equals x 28th divided by 4. That's what the fourth root of x 28 is, right? Times z of the 24 divided by 4. Okay, so when you take a root of something, so if you take the, you know, let's see, is there a rule right there? Let's see. Don't have, yeah, I don't have that. Okay, so if you have, you know, m root of x times n, that just equals x raised to the n divided by m power. Okay, I guess that's a property I didn't list before, but if you do that, then that gives you, okay, x raised to 28 divided by 4 gives you the 7th power. Okay, now here there's a problem because when it's the 7th power, okay, any odd power can be a negative number, right? Because you know, a negative number can be multiplied by an odd number times and you would still have a negative number. For example, -3 raised to the 3rd power equals -3 times -3 times -3. That gives you -27, right? However, we started with x raised to the 28th power, so that means in the original formula here, the original function here, x has to be a positive number, any even number power, right? So -3, whoops, sorry, raised to the 2nd equals -3 times -3. So whenever you have an even amount of numbers timing each other, timing themselves, then that gives you a +9. So any even number power only can exist as a positive number. So when you have x raised to the 7th, this could potentially be negative. To make sure you're completely accurate, you have to put a absolute sign there to make sure it stays positive, because x raised to the 28th power in your original function there has to be positive. Does that make sense? Is everybody with me? Okay, so then times z, 24 divided by 4 is z raised to the 6th power, and that is always positive, so we don't have to worry about a absolute sign there, divided by 3. So this is the simplest you can get it to. So when I say simplify, you know, that big chunk of mess right here, you can simplify it down to this eventually. Okay, now is that the same answer you got, or somewhere along the line?
This all makes sense now.
Okay,
and
good.
that one I sent you to as well, I was able to solve that.
Oh, good, perfect. All right. Okay. All right. Any other questions from chapter 0? Now, let me go through this and just see if there's anything I would like to mention if you guys don't have any questions.
When you simplify an improper fraction, like 5/3, would it be 5/3 or would it be 1 2/3?
Either way works. Like, to me, you know, either way is the simplest form it can get to. So I won't dock you for, you know, 5/3 if that's what you want to leave it to. Okay. Yeah. Okay, but you know, or you can do 1.3. Or wait, no, 5/3 is not 1.3. It's 1.67, 6667. So yeah, leave it as either 1 2/3 or 5/3. Okay. Okay. Let's see. Anything else I want to mention? Okay, let's just do one more practice and see if you guys can figure something similar out, right? If I were to ask you to simplify, you know, the 3rd root of 54 times x to the 3rd plus, okay, the square root of 50 times x squared, what would that equal? you guys got it figured out yet? Yeah, okay, so let's look at this together, right? So again, this equals, you know, the third root of 54 times the third root of x plus, okay, the square root of 50 times the square root of x squared, okay? So then the square, 54, third root of 54 is what? Let's see, easier to do 27 times 2, okay? And whoops, sorry, I forgot this power here. I was just thinking this equaled x, so skipped ahead a little bit, okay? And plus the square root of 50 equals 25 times 2 times x here, okay? And that gives you, the third root of 27 times the third root of 2 times x plus the square root of 25 times the square root of 2 times x, right? So you get 3 times the third root of 2x plus 5 times the square root of 2x, and then whatever that combines to, okay? But anyway, so hopefully this makes sense now, right?
Could you combine the x's, or
You can, yeah. So then this equals 3 plus 5 square root of 2 times x, right? So you can pull x out as a common factor from both expressions. Yep. Yep. All right. Okay, so let's see. Any other questions from chapter 0?
Actually, a question for this. Like if you gave us this exact question and said to simplify, would you want us to, take the x out at the end of that, or would the one right above it?
I think that the last step probably makes it look a little bit neater. Yeah.
Okay.
Yeah. Okay. All right. Let's see. Yeah. Any other questions from chapter 0? And you guys all remember the FOIL rule or FOIL method of multiplying through parentheses, right? So if I have, 3x plus 8y times x plus 2y, and I want you to expand this into, a normal equation or expression without parentheses. Do you remember how to do that? Okay, I had to look it up today, and because when I learned this, I never heard of anything called FOIL because it was in China, right? So FOIL means first you multiply first number, then you do the outside numbers, then you do the inside numbers, then you do the last number, right? So the first numbers is this equals 3x times x, right? So the first number is right here, okay? Then plus the outside number, so 3x times 2y, so it's this, this one again, this one right here, right? Plus the inside numbers, so it's 8y times x, plus the last number, so 8y times y. That's how you expand in parentheses, right? So then you can combine, oh, sorry, my daughter's speaking, I'm working. And so then you can do this equals 3x squared plus 3x times 2y is 6x and y plus 8x and y plus 8y squared. So the middle two terms can be combined again. So this is 3x squared plus 14xy plus 8y squared. Okay. So yeah, the FOIL just stands for, first, outside, inside, and last. Okay. All right. Did that ring a bell? Okay, good. All right. No more questions in chapter 0?
One more question. Could you think of like a more complex or difficult like factoring, like with polynomials? Like I feel pretty confident on it, but I don't know if there's anything that would be good to review, like that might catch us up.
Okay, let's think. Well, are you saying like similar to what we just did, but more with more
so it's in point 6. I mean, it's pretty straightforward for the most part.
Mm-hmm.
But you know, it's fine. Never mind.
Okay, all right. Now I'm just trying to think how I can make it more complicated. I guess the only thing I can think of is just having more terms and then more powers, but the same rules will apply, right? So maybe as long as you know when 3x cubed times 5x squared equals 15x raised to the 5th. I think if you know the rules like this, then you'll be fine, right? So you multiply the numbers together, and then xm times xn equals xm plus nth power, right? So that's the rule behind this. And so if you remember these, you should be okay. Okay. All right. Okay. Any questions in chapter 1? It gets slightly complicated because now you actually have linear equations with one variable that you need to solve. So of course, when you only have x, and that is called the first degree equation, right? And x squared is the second degree equation, etc. So the more powers, one thing to remember is the more powers you have on your x or y or z, whatever you're trying to solve, the more solutions there are to each equation, right? X first degree equation only has one answer. X squared, you have 2 answers that can solve the same equation. X cubed, you'll have 3 answers that will solve your equation. So the number of solutions will coordinate with the number of powers you have on your unknown that you're trying to solve. Remember that. And so if you only, if you're solving an equation with x squared in it and you only came up with one solution, you're missing something. You got to go back and find another one, because x squared means there are 2 answers that can solve your problem. Okay. All right. So let's start with a simple one and work our way up a little bit. So let's do 3x plus 2 times x plus 5 equals 5 times x minus 1. Okay, I'll give you a minute and see if you can figure out what the answer equals to. So here, x is only 1, has 1 power, the first degree equation, so there should only be one x, one solution to x, I should say. Okay. All right, you guys got the answer? Okay, let's work this out together. So this equals 3x plus, you multiply 2 into the parentheses, you get 2x plus 2 times 5 is 10. And do an arrow instead of equation. So this, you multiply 5 into the parentheses, that equals 5x minus 5 times 1, which is 5, right? Everybody with me so far? Okay, so then that equals 5x plus 10 equals 5x minus 5. Now, whoops, yeah, see, is that right? Yeah, that's right. Okay, so now, well, that can't be right.
Is it gonna be like undefined or no solution?
No, it can't be, yeah, well, let's see.
Because if you get rid of the
Right.
5x, and then yeah.
Yeah. So did I, oh, let's see, did I write the equation wrong somehow? 3x plus 2x, 10 equals 5x minus 5, yeah. So, well, this, yeah, whoops.
But
This
I'm not
is,
the only one that's struggling with this.
I know, right? What did you guys get? 'Cause
No, I got no solution as well.
yeah, so now that's a bad example because I just randomly picked a equation in the book with no solutions. Whoops, sorry, this is a bad
Take
example.
2x plus 5 in the bracket, the parentheses, then you can do it.
You mean, get rid of, oops.
Just in front of the, where you have 3x plus 2, yeah, I just put 2x and then put
Yes.
the 2 in front, and then it would not be equal to 0.
Okay, yeah. All right, well, yeah, so then that, if we change that, that would just change this to 5, right? Change this to plus 5. No, that can't be right. That's still,
Wouldn't that still be undefined?
yeah, that's still undefined, yeah. So, all right, cross this one out. I'm sorry for giving you a bad question to solve. I didn't, like I said, I didn't have to prepare ahead of time what I needed to work on. I didn't think there were question answers with no solutions. Let's go a little bit more complicated, I guess.
But that's a good example because there's some exercises like that in the whole homework, so you're gonna be able to answer those type of questions.
Yeah, just say undefined in that case, I guess.
Yeah.
Yeah, all right. So let's do a new one. Okay, let's do negative 5x divided by 2 plus x minus 2 divided by 3 equals negative 3/4. Okay, let's solve this one instead. Okay. All right. You guys got the answer yet? I'll need a little bit more time. Okay, so I want to look at this together. Okay, so this is also something you will see for this chapter where you have these fractions with one unknown to solve. And whenever you have these fractions, the first thing to do is to find what?
Common denominator.
Yeah, you want to find the lowest common denominator or common multiplier for these denominators, right? So 2, 3, and 4, the smallest common multiplier they share is 12, right? So you want to multiply every term by 12 in this to begin with. So you do 12 times 2 negative 5x plus 12 times x minus 2 divided by 3 plus, whoops, not plus, equals 12 times negative 3 over 4, right? Since you multiplied every term by the same factor, then the equation still stands. The only difference is now, okay, 2, divided by 12, that gives you 6. So this is negative 30x plus 3 divided by 12 gives you 4. So this is 4 times x minus 2. That equals, okay, 4 divided by 12 gives you 3. So 3 times the negative 3 is negative 9. Right? Everybody with me so far? Okay. If you have a question, like I said, please ask. Don't just let this pass you. Okay. So now you have negative 30x plus 4 times x is 4x, minus 4 times 2, which is 8. That equals negative 9. Okay, so then that equals negative 26x, and you add 8 to both sides, right? That's what you're doing here. Then this side, the 8 will cancel out, and that gives you negative 1. So, and then x in that case, if you divide by both sides by negative 26, you get x equals 1 over 26. Right? That what you guys got? Or you got a different answer?
I have a comment.
Hmm?
Is it confusing to use the multiplication sign in, I don't know, like too many x's?
Too many x's? Okay. Yeah. All right. I'll try to do a dot. How's that from now on? Okay.
Yeah.
Good. Yeah.
Dr. Ma.
Yeah.
Instead of, I still got the same answer. I'm just wondering if there could be problems. Instead of multiplying them all by 12, I just brought their denominator up to 12, so I multiply them respectively of whatever gets them there, and it got the same answer.
Yep. That's exactly what you're doing. When you do 12 multiply everything, that's really you're just multiplying the numerator. Or yeah. Or you saying you just got the denominator to be 12, you said? Yeah, that works too. Yeah.
Yeah.
That works too. Yep. So essentially, you're just skipping one step where instead of multiplying everything by 12, when you say you did every denominator to 12, then you've already skipped the first step that I was doing here, actually. But it's the same thing. Yeah. Okay.
Okay, cool.
Yep. Good. All right. Any other questions? Okay. You guys need a little break? It's been an hour of math. Yeah, okay, let's take 5. Stand up and I'll pause the. All right. Okay, a couple more things I want to talk about well, actually, we haven't gotten into inequality yet. A couple more things I want to talk about with linear equations in chapter 1. Okay, one is you could have an equation with just complete letters, and then it will ask you to solve for one of the letters. You got to just apply the same rules. It will look extremely abstract, but it's the same thing. For example, okay, if we have, let's say, A equals 2LW plus 2WH plus 2HL, and then I ask you to solve for little w, okay? Can you do that? See if you can solve this one. Let's take another couple minutes. Okay, you guys need more time? Okay. All right, so let's look at this. Okay, so when I give you this whole equation with all letters and then ask you to, not all letters, I guess there's some twos in there, but ask you to solve for one of the letters, then you just treat the one you're solving for as the unknown and everything else as a number, as a constant. Okay, so that's how you solve for this. So then the way to do this is you say, okay, well, now I want to pull W, like I want to put W together as one term because that's the unknown I want to solve. So that means this becomes 2L plus 2H times W, right? Because you just combine these two terms and pull W out as a common factor. Everybody with me? Okay. And then plus 2H and L. And then you just subtract 2HL on both sides. So A minus 2HL equals 2L plus 2H times W. And then over here, you know, if you do 2HL minus 2HL, then they cancel out. Okay. Then you just divide both sides by the parentheses. So 2L plus 2W. I mean, not 2W, sorry, 2H. Okay, on this side, you divide 2L plus 2H. So then that gives you W equals A minus 2HL divided by 2L plus 2H. Okay. Did everybody get this same answer? Okay. All right. Good. Okay. So I guess if you want to, you can, you know, do 2 times L plus H, but that doesn't really matter. I don't think that simplifies any further. Okay. All right. So another thing that, you know, you can use this particular type of equations for is to actually solve story questions, right? So of course nobody really likes story questions, but that's really what math is good for, right? The ultimate goal is to use math to solve real situations, which are, you know, real story questions instead of fake ones. So
that's all
yeah, go ahead.
economics is. So
that's right. That's all.
I think we're pretty used to it for our test.
Good. Yeah. So let's see. Okay, let's do a simple one, right? So since we don't have, you know, I don't want to write down a bunch of you know, sentences on here to give you the scenario, and it's hard for you to just listen and memorize things. So let's say that you know, Troy buys a system, stereo system, okay, sound system, and the price listed is $8,820, right? Troy is throwing a lot of money into the system, but at the end, Troy paid, the total price Troy paid with tax, turned out it is $9,702. Okay, I guess no dot there. Okay, then my question is, what is the tax rate? Okay, figure that one out. Should be, hopefully it's not too difficult. Okay. Can you guys hear my son playing the piano? Okay, good, because I'm hoping he's not distracting you. I can hear it very faintly. He's practicing his piano, but I don't want you guys to have background music necessarily. So. You guys got the answer yet?
Did you want us to find the tax percentage?
Yeah.
Like the total?
Yeah. When I say tax rate, that's I'm talking about percentage. Oops, sorry. All right, let's look at this together, okay? So let's call the total amount of paid money as cost, okay? So the way to look at this is your price times 1 plus your tax rate equals your cost, right? Everybody agree, right? Your original price times 1 plus the tax gives you the total cost. So if you know that, then it's 88.20 times 1 plus t equals 97.02. So you divide both sides by 88.20. Or you can multiply 88.20 into, I guess I told you guys I'll just use the dot. So let me change that to the dot. Okay, and then if you do that, you get 1 plus t equals, on this side, what is 97.02 divided by 88.20? Should be 1.1, right? So yeah, t then equals, you subtract 1 on both sides, t equals 0.1 or 10%. Okay.
Hey, Brother Ma, I thought of a different way that I think would work.
Okay.
Just tell me if there would be a problem with this in other problems. So you could subtract 8,820 from the total cost, and that will give you just the tax.
Right.
And then divide that by the normal price.
Yep, that's exactly the other way. So if you start right here, you know, like we did just now, and then what you did was you multiplied, I mean, you skipped a couple steps, but you multiplied 88.20 into the parentheses. You got 88.20 plus 8820t equals 9702. Then you subtract both sides of 88.20, and then you get 88.20t equals $882. Then you divide both sides of 88.20, 20, then that gives you t equals 0.1, right? So that's what you did. That's absolutely correct. Okay. Okay. All right. Good.
I have a quick question too. This kind of,
yeah.
On the test, are we going to be allowed any kind of like note card or anything at all for equations?
I haven't thought about it. Let me think about it. But I don't think a note card necessarily will help you a whole lot, because there's no equations to apply to any situation.
I guess that's true. Yeah.
It's really just math skills. So
sure.
I mean, I guess you could write down some properties, but without practice, it's probably
it wouldn't be worth it. Okay.
But I'll think about it. Okay. Okay. All right. Any questions you have from what we just covered, the equation part in with one variables in chapter 1? Okay. If not, then let's get into inequalities. Okay. So inequalities, really, I mean, it's equations changed the sign from equal sign to an inequality sign, and but the way to solve it is quite similar. I can't say always the same, right? Because the biggest difference is, when you multiply both sides with a number, whether that number is positive or negative will change what results you get, right? So for example, if you have a less than b, and now you multiply both sides with d, so a times d and b times d, what happens to this inequality depends on if d is greater than 0 or not, right? So if d is greater than 0, which means it's a positive number, the same inequality sign will hold, the same unequal relationship will hold. But if d is actually less than 0, that means it's a negative number, then a less than b will give you AD. I guess I better do an arrow here. AD will be greater than BD, okay? Because when you multiply a bigger number b with a negative number, then that will make it actually smaller now, okay? Because it makes it more negative. Does that make sense? So this is one of the things to always keep in mind when you work with inequalities, okay? So now let's start with some examples, right? So here, again, you're solving for a solution, but the solution is no longer x equals something, it's x greater than or greater than equal to or less than equal to something, right? So let's say, we have 5 minus 2 times x minus 3 is less than or equal to negative 1 minus x. Okay, see if you can figure this one out. Okay, you guys got the answer figured out yet? Think? Okay, so let's look at this, right? So the way to approach your inequality is just the same as an equation until you encounter multiplying anything that possibly can be negative, right? Then you stop and treat it differently. But for now, let's just approach it as if it's an equation, right? So this is 5 minus 2 times x, then negative 2 times negative 3 will give you positive 6, less than or equal to, okay, negative 1 plus x, right? Everybody with me so far? How I got here? Okay, and then I want to put all the x's on one side and all the numbers on the other. So this is 5 plus 6, then you add add 2x on both sides, right? Because you can do negative 2x plus 2x less than or equal to negative 1 plus x plus 2x, right? So you just added plus 2x on both sides. You can add the same thing on both sides of an inequality and it'll still hold, right? So on this side, plus 2x minus 2x will cancel each other. So that gives you 11 is less than or equal to negative 1 plus 3x, right? Okay, now you want to add 1 on both sides, then this side plus 1 minus 1 cancel each other. Okay, so you get 12 is less than or equal to 3x. Okay, then you can divide both sides by 3, and because it is a positive number, you're dividing, or it's the same as multiplying 1/3, if you will. Since you're multiplying 1/3 to both sides and it's a positive number, that does not change your inequality sign. So that gives you, Okay, x is greater than or equal to 4. Okay. Is that the same answer you got?
Furthermore,
Yeah.
I think you just clarified, but I just am double checking. So the only time you'd flip your inequality sign is when you are dividing by a negative, right? That's the only time.
Or multiplying by a negative. Yeah.
Okay.
Yeah. Because dividing, dividing by 3 is the same as multiplying 1/3, right? So division is one way of multiplication, really. But yeah, when you're dividing or multiplying by a negative number, then you need to flip your inequality sign.
Okay. Thank you.
You're welcome. Okay. All right. See, now the way to express this solution you got, there are 2 ways to do it, or 3 ways, right? One is you can leave it like this, x greater than or equal to 4, or you can do it in a set situation, right? So this means since it's greater or equal to, you have the bracket here, and 4 to infinity is your answer, right? So you say x belongs to this set. That's another way of expressing the same answer you just came up to, okay? And then another way that we will not really use, but is also correct, is draw a number line, right? So if you draw a number line and says, okay, so here's 0, here's negative infinity, and then you have 1, 2, 3, 4, and maybe I'll extend this out a little bit. Didn't mean the whole thing. Okay. This is infinity, okay? Then you can say, okay, so the answer is that it includes 4 and the rest of the number line to infinity, right? So this would be another way to express your answer, but this is more used for little kids when they first learn this. But I wanted to point out it is one way, but okay. I'm looking for usually the first 2 ways to give me your answer. Okay. All right. That makes sense? Okay. Now, let's talk about inequalities with absolute values. Okay. That one is can be a little bit tricky, right? So let's start simple. What if I have 4 minus 2x in the absolute value is greater than 6? How do you solve this? Okay, so go ahead and work on this and see if you can get it. Okay, you guys figured it out yet? Okay, yeah, so the way to do this is you remember, well, the absolute value can be a positive number or a negative number, right? So there are 2 possibilities. One is that 4 minus 6 is a positive number. In that case, it is greater than 6, right? So then you just solve it, and this equals, 4 is greater than 2x plus 6. You just move 2x to the other side and change the sign, right? And then that gives you, okay, you move 6 to the other side of the inequality and change it to negative 6. So 4 minus 6 is greater than 2x, okay? And that gives you negative 2 is greater than 2x. Divide both sides by 2, you have x less than negative 1, right? Okay, and you can always plug this in to your original equation to see if it's true, right? So x less than -1 means -1 is not included. So if we were looking for the next whole number, so you can go to -2, you plug -2 here, that will give you 4 minus 2 times -2, which is 4 minus 4, which will give you +8. And +8 is greater than 6. That's correct, right? Okay, so the second possibility is that 4 minus 2x is a negative number. Then in that case, the negative of 4 minus 2x is greater than 6. That's the other possibility, right? So then again, you just do the same thing and solve this. So this equals -4 plus 2x is greater than 6. Okay, so you add 4 to both sides, then that gives you 2x equals, oops, sorry, not equals. 2x is greater than 6 plus 4 is 10. You divide both sides by 2, you get x is greater than 5. Okay, so again, you can plug this into x, your inequality, and check. So the next whole number is x equals 6. So 4 minus 2 times 6, and 2 times 6 is 12. 4 minus 12 is -8. -8, the absolute value is +8, which is greater than 6. So that's how you find these two solutions. Okay, that makes sense? Did everybody get it right? Or you have any questions about this? Okay, so when you do the inequality one, just remember you got to solve for, the positive case and the negative case. And then you'll have all your bases covered. Okay. All right. Okay. The next part is the quadratic equations in this chapter. Okay, with one variable, and that is saying when you have a square term for your unknown, right? Quadratic comes from the Latin word quadris, which means square. Okay, so the general form is ax squared plus bx plus c equals 0. And here, a, b, and c are real numbers. Okay, so a, b, and c are real numbers. Okay, and a does not equal 0, because if a is 0, you don't have a quadratic equation, right? And then I'm sure you all hopefully still remember the solutions to your quadratic equation, right? So that is x equals, okay, -b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so there are two answers because x is a square term now. So we said the power of x tells you how many solutions you have. So -b plus square root of b squared minus 4ac is one answer. -b minus 1 is the other answer. Okay, so that's the general way of solving for this. And
how do you write the answers again for that too? Do you write it?
Okay, so you do x1 equals -b plus square root of b squared minus 4ac divided by 2a, and then you do x2 equals -b minus square root of b squared.
Okay, so you would just write x1 equals whatever that is in x2.
Yeah.
Okay.
Yep, x1 and x2.
And then is that something for on the exams too? Like, for example, if we're missing like an x1 or x2, but you could see that we did the work, will we lose points? Or as long as we've done like things properly, are you more lenient about that?
Well, I guess it depends on what you write, right? If you write something that's not correct mathematically, then I'll have to mark it wrong. But if you do, x equals 4 or x equals -4, then I'll count it as right.
Okay.
Or you can do x1 equals 4 and x2 equals -4,
Okay.
Yeah, but if you do like x equals 4, comma, -4, I know what you mean, but it's not necessarily a traditional mathematical expression, right? So
Okay.
I might just mark you and take a little point off just so you pay attention and say, hey,
Okay.
don't write it in a very loose, non-mathematical way.
Okay. Thank you.
Yep. All right, so armed with this knowledge, or I guess, reviewed with this knowledge, let's work on a couple of examples and see if you can figure this out, okay? Oh yeah, so I guess let's make things a little bit more complicated, okay? So instead of me giving you a ready-to-go equation, let's say, what is y minus 9 squared equals 16? Solve for y. So you have to actually expand the y minus 9 squared first, okay? So see if you can get the answers. Okay, you guys got it figured out yet? I'll give you another 20, 30 seconds. All right, so let's look at this together, okay? So hopefully you remember how to quickly, express y minus 9 squared, but just in case you don't remember, I'll do the slow way, right? And, so that y minus squared is y minus 9 times y minus 9. So using your FOIL rule, that means y squared minus 9y plus 81, right, equals 16, right? So you just time these two terms together, then these two terms together, these two terms together, and then finally these two numbers together, right? So, but anyway, so that gives you y squared minus 18y, okay? And then you subtract 16 on both sides because you want the right-hand side to be 0 before you can use your quadratic equation. So 81 minus 16 gives you, what, 65, right? All right, okay. So now you can use the quadratic equation. You say y1 equals, okay, negative b is negative 18, right? Remember, we had this here. B is this number in front of your y right here. So negative 18 is positive 18, okay, plus the square root of, okay, 18 squared minus 4ac. A is 1 because, in front of y squared is just 1 times y squared. So that's 4 times 65. Right, and then divided by 2a, which is just 2, okay? y2 is negative b, which is negative 18, gives you positive 18 minus, okay, 18 squared minus 4 times 1 times 65 divided by 2, right? Okay, and then you just need to do this, solve this number. Let me use my calculator. Can't do it in my head that quick. Okay, minus 4 times 65. Okay, so the square root works out nicely. And this is 18 plus the square root of 64. Okay, divided by 2. And this is 18 minus the square root of 64 divided by 2. And the square root of 64 is 8, right? 8 times 8 is 64. So that means y1 equals 18 times 8, I mean, sorry, not times 8, plus 8 divided by 2, which is 13. Okay, then y2 is 18 minus 8 divided by 2, which is 5. Okay. Any questions? I hope you got the same answers, but if you didn't, please tell me if what I did makes sense.
I solved it way shorter, and I
Okay.
got the same answer.
Okay. Yeah, that's good. If you can, yeah, get the same answer. I mean, another way of trying to do this, you know, since this is squared, you can just take the square root of, both sides, and you get y minus 9 equals, you know, the square root of 16 is either 4 or negative 4, right? So
that's how I did it.
yeah, so that's another way to do it, but I want you to practice your quadratic equation, right? So that's why I didn't go this way, but that's definitely another way to do it, okay? All right, any other questions? Okay, so let's make things a little bit more complicated, okay? Where we'll have higher degree polynomial equations that are what's called quadratic-like or quadratic in form, okay? What I mean by that is you have, you know, a form where it says it's little a times, you know, big A squared plus b times big A plus c equals 0, but where a equals a whole nother equation, right? So a whole nother equation all by itself, okay? The way to do this is then you still solve for a first, okay? And then once you have the a solution for a, then you solve the variables in a. Okay, let me give you an example of what I mean. Okay, so let's say we have x minus 6x, sorry, x squared minus 6x, then squared again, plus 2 times x squared minus 6x minus 15 equals 0. Then I'm asking you to solve for x, okay? So one way to do this is to notice, okay, this term here and this term here are exactly the same, right? So instead of trying to expand everything and solving for x, you can just solve for x squared minus 6x first. Now this is not too complicated necessarily, but if you multiply this through, x squared, squared again is x to the 4th power. That can be pretty complicated to do, right? So let's call this a, right? And solve for a first, where we know a1 equals -2 plus, okay, 2 squared, which is 4, minus 4ac. So 4 times 1, this is 1 in front of a, right? So you don't need to write that out. And c is, so -15, okay, divided by 2a, which is 2, right? And a2 equals -b, so -2 minus 4 minus 4 times -15. And divided by 2. Right? Everybody with me so far? Okay, so let's solve these really quick, where a1 equals, okay, -2 plus the square root of, so it's 64, right? 4 minus -60 is, 4 plus, 4 minus -60 gives you 64, right? That's 4 plus 60 divided by 2, okay? And this is -2 minus 64 divided by 2. And 64, again, we already know that's square root of it is 8. So -2 plus 8 is 6. 6 divided by 2 is 3, right? And then -2 minus 8 is -10. And -10 divided by 2, oops, is -5, right? Everybody with me so far? Any questions? Okay. All right, so once you have this, then you can say, okay, well, that means x squared minus 6x equals 3, or x squared minus 6x equals negative 5, right? Because that's what a is. A is x squared minus 6x, okay? Then you can solve it again using the quadratic equation. So this is x squared minus 6x minus 3 equals 0, right? And this is x squared minus 6x plus 5 equals 0, right? Everybody with me? Okay. Then if you do the quadratic equation, you can do x1 equals, okay, negative b, which is positive 6, plus the square root of b squared, which is 36, minus 4 times 1 times negative 3, right? Divided by 2. X2 is negative 6 is positive 6 minus square root of 36 minus 4. Oh, I keep forgetting to use the dot. I'm sorry. Whoops. That was way too much. Okay, so that is 4 times negative 3, okay, times negative 3 divided by 2. Okay, but that's not over, because here we also have x3 equals, okay, 6 plus the square root of 36 minus 4 times 1 and then 5 divided by 2. Then x4 equals 6 minus 36 minus 4 times 5 divided by 2, right? Everybody with me so far? Any questions how we got here? Okay, then we just need to figure out the numbers, right? So x1 equals, here, okay, 6 plus 4 times negative 3 is negative 12. 36 minus negative 12 is 48. So the square root of 48 divided by 2. Okay, and okay. Wow, didn't mean to get rid of the whole thing. Okay, so that equals 3 plus, okay, square root of 48 is what? 16 times 3, right? And square root of 16 is 4. So that's 3 plus 4 times the square root of 3 divided by 2, which is 3 plus 2, the square root of 3. Okay? And x2 then equals 3 minus 2 times square root of 3. Okay? Then x3 equals 6 plus, okay, 36 minus 20 is the square root of 16 divided by 2. So that is 6 plus 4 divided by 2, which is 5. Then x4 is 6 minus 4 divided by 2, which gives you 1. Right? Did everybody get the same answer? Or you're just planning on watching this video again later to figure it out? Don't do that. Ask questions if you have them right now, okay? Now this should make sense, right? Because if you look at the original equation we started with, you have an x squared, then squared again. So that means the highest power was x to the 4th power. So that means you should have 4 solutions, okay? And you can always plug in all 4 of these answers back into the equation and see if you get exactly the same. I mean, if the equation will hold, you can plug in x equals, right here, you can plug in x equals 5 and 1 and 3 plus 2 square root of 3 and 3 minus 2 times square root of 3. And all those should work out to be 0, okay? So that's one way to verify, of course.
Brother Ma, I have a question.
Sure.
So just to verify, for this question, the original time that you do the quadratic formula, you're treating x squared minus 6x as if it's just x.
Right.
Because it's like x squared plus.
Yeah, we called it a, right? That's why we had a1 and then a2 right here.
And then you solve for x squared minus 6x is equal to -5 or 3, and then you have to do the quadratic formula again.
Again, right. Right. So this is called the quadratic-like equations, which are higher degree polynomial equations, but because they do take this form that looks just like a quadratic equation, you can solve them much easier than trying to solve x to the 4th power on your own. So it just takes 2 quadratic equations to solve this whole process. Okay?
And it only works if there's like terms like that
at
the beginning.
Right. Otherwise, then you have to figure out other ways to do it. Okay? All right. Any other questions? Okay, we have just the last few minutes, but I do have one last thing, which is rational and radical equations. Okay, so that's where you have a proportion in equation where x is in the denominator. Okay, then you got to figure out how to solve it, right? So let's say, see, what can we do? Let's say you have maybe -x divided by x plus 6 equals -1 divided by 6. And I want you to solve for x, okay? So how do you do this one? Okay, let's work on this because I have one more thing I do want to show you. Okay, so here, the way to solve this is you got to get the x out of the denominator, right? And the way to do that is to multiply x plus 6 on both sides. Okay, so then on the left-hand side, they cancel. You get -x equals over here is x plus 6 times -1, which just makes it negative, divided by 6, right? Everybody with me so far? Okay, and then you still have a 6 in the denominator you want to get rid of, so you do the same thing, multiply both sides by 6, then this time this side cancels out, you get, oh, so that's 6 times -6 and -x, okay? So you get -6x equals -x minus 6, right? Everybody with me? Okay, so you want to then add an x on both sides. Then again, on the right-hand side, -x and +x cancel out. On the left-hand side, -x plus x is -5x. That equals -6. Divide both sides by -5. You get x equals -6/6. Okay, is that what you got?
It would be positive, wouldn't it?
Oh, right. Sorry, it's not negative. Yeah, negative. Thank you for correcting that. Yeah, negative divided by negative is positive. Okay. All right. So the last thing I want to show you is, well, sometimes you have to solve, okay, an x that's in some kind of root, right? So what if I have x raised to the 2/3 power minus 125 equals 0? How do you do this one? Well, because of time, I'm not going to give you time to work on this. But if you recall, we have said before, x raised to the 3 seconds power is really x squared, and then taking the, x cubed, taking the square root, right? Minus 125 equals 0. Okay, so then this equals the square root of x cubed equals 125, right? The way to then solve this is to raise both sides to the square term. If you square both sides, then you get x cubed equals 125 squared, which is what? So let's see. 125 squared is 15,625. Okay, and now you can solve this by then taking the cube root, or the third root of both sides, so x then equals, remember in this case, since it's an odd power and that equals a positive number, so that means it can only be the positive root. So you don't have to do plus and minus because it's not x to the fourth power or x squared. Okay, so if you take the square, the cube root of 15625, that gives you 25. Okay, but the key here is to transfigure this into this form and then squaring both in to make x appear with a normal power instead of in some kind of root. Okay. All right, so we're out of time, and this, I just went over the basics. The only way for you to be good at this, to learn, is to do the lots of practices. So like I said, half of you haven't even started chapter 0 and chapter 1. Only one of you, finished beyond chapter, only 4 of you finished chapter 1 and 0. The rest haven't finished it yet. So please go back to the modules and just click on each section. Okay, the first number is the chapter, the second number is the section, so 0.1 through 0.5 or 6, and then 1.1 through 1.6. You got to finish that before next Wednesday, which is the due date. And then in the meantime, though, that doesn't mean you don't look ahead. I'm actually considering changing the due date, maybe moving it up to Monday, so you don't just keep doing this till Wednesday and not have time to get ready for next week. Because next week, before Tuesday's class, I will post a video going over the key terms and the key points for chapter 2 before Tuesday's class time. So please make sure you have been reading chapter 2 and doing the learn part at least, and possibly practice part as well, and then watching the video before Thursday, and then we will talk about chapter 2 in class on Thursday. Okay, answer any questions you have, and I'll give you some exercises much like today, and then we'll solve it together. But again, the only way for you to do it is to do a lot of practice. Okay. All right. Okay. Well, thank you. You survived a 2-hour math class in the afternoon, so that's not bad. Yeah. Go enjoy your afternoon and the long weekend. I'll see you guys next Thursday. Okay.
Thank you.
You're welcome.